Okay, so we were talking about force and acceleration. Well, once again, if it's not accelerating, the force is zero, but it can still have forces on it. As long as the sum of the forces is zero, that implies the acceleration is zero. And so all we have to do is maintain the sum of the forces equal to zero. Now, think about this. Apply force or something, you can obviously like pull on it, but if you tie a string to it, then what happens is this object is experiencing force right there where the string is hitting it. You're pulling on the string here, so what's happening in the string? Well, if you had a string or something, you cut it and put a meter in there, you would find force in here all along the shore. Wherever you put that meter, the force meter, you'd find the same force. So that force is distributed along the string. So what's happening? Well, the string is made up of atoms. So we have all these atoms in here that make up the string. Now I'm not going to draw all the atoms, obviously. So what happens is all the atoms they interact with each other. They have their preferred places. So if you pull on it, that kind of pulls this atom out of position. That means that these other atoms pull back on it, but because for every force is an equal and opposite force, they're pulling on those other atoms, which pulls them slightly out of position, which makes the other atoms pull on them, but it pulls back. So back and forth, all up and down this string is this force, and we call that the tension. Okay, so the tension is the force distributed along the string. And so if my string is curved, like it goes around a pulley here, then what happens is we have tension along the string here. Okay, the tension's pulling this way and this way in the pulley, so the pulley has to be pushing that way. So that means they're forced this way on the pulley. Okay, and but the end result is that the tension is the same all the way around the pulley. Now that turns out to be a very useful sort of thing for us. So let's imagine we have a ceiling up here and we're hanging a 100-pound object from the ceiling. So that means that gravity is pulling down with a force of 100 pounds. The tension is pulling up. Now, if it's hanging here, that means acceleration is zero. So F equals ma. So if the acceleration is zero, that means the total force is zero. Well, we look at this, we have tension this way, we have the 100 pounds the other direction, so the two of them have to add together to be 100 to add to zero, so the tension has to be 100 pounds. Okay. Well, let's look at another example. Let's say that we've got a table here and it's up against the wall. And we have a 100-pound object hanging off here. There's a pulley and it's tied to the wall. So I want to know what is the tension in there. Well, same thing. What you do is you look what I call the politician view. You just look at the 100-pound object. You ignore everything else. Again, politician view. You only look at the one thing you're interested in, the 100-pound object. And so we have tension pulling up. We have gravity pulling down with 100 pounds. It's just hanging here, acceleration zero. Therefore, the tension is 100 pounds, which means that it's pulling on the wall with a force of 100 pounds. So now let's consider that we have a table. Okay, we have a 100-pound object here, pulley, comes to the other side of the table. We have a 100-pound object, and I want to know what's the tension. Okay, well, again, politician view. I don't really care about the thing on the right over here. This is the congressional district that I'm interested in right there. So that's the only thing that matters. And so, politician view. If you look at only this one object, you have tension up, you have mg down, and it has to add to 0. Therefore, the tension is 100 pounds. If you look at this one over here, you get the exact same thing. You get 100-pound object, so tension's pulling up. mg is down. They have to equal each other. The mg is 100 pounds because we said it's a 100-pound object. Therefore, the tension is 100 pounds. Okay. All right. So, what I've done here is, what I'm calling the politician view is actually called a free body diagram. What I do is I zoom in on the one object of interest and I draw it. And I label everything, label all the forces. I label any acceleration. If there's an acceleration, I use that as my strategy to solve. So let's do another example. So we have the ceiling up here. Okay. And I have a 100-pound object. I have a pulley, and I have a rope that's tied down here, goes over here, goes over another pulley, and I want to find the tension in that rope. Now, if I zoom in right here, do my politician view, okay, then we have the object. We have mg, 100 pounds, pulling down. We have two tensions pulling up. Now, again, the politician's too stupid to notice it's all the same thing. Okay, so what we do is we look at it and say there's two tensions pulling up, and we have to know they're equal. So 2T pulling up has to balance 100 pounds. So tension is 50 pounds. Okay, so we got 50 pounds. So that means my pulley has magnified the force. So now a 50-pound of force pulling can hold a 100-pound object. In fact, as long as you're going at constant speed, the 50 pounds of force can lift the 100-pound object. Okay, so let's continue. So we have the ceiling here. Okay, we have a nesting of pulleys here. So we have a nesting of pulleys, and we have a rope that goes from here over that pulley, down here around that pulley, up here, comes down here around another pulley connected to that, comes up here and down like that, and then this is connected to a 100-pound object. And I want to know what the tension. Okay, free body diagram, the politician view. We have our object. We have gravity pulling down with 100 pounds. We have 1, 2, 3, 4, 5 tensions pulling up. So that means that 5T is 100 pounds. So the tension is 20 pounds. Okay, now, again, all we did was we used pulleys. Okay, so the pulleys, okay, it's a form of wheel, is one of the simple machines. So the simple machine, what does the simple machine do? What does the pulley do? You look at it and say, well, it can change the direction of the force. Well, it did more than change the direction of the force, because if the force is directed back this way, then you've actually kind of magnified the force. And so what happens is you now have a mechanical advantage. The mechanical advantage is basically the multiplying of your force. And so you multiply the effect of the force by using the pulleys. For example, the nested pulleys, that's how block and tackle works. So the block and tackle then is going to give you a mechanical advantage. Depending on how many pulleys are there and how many times this loops around, you greatly magnify the force. So that way, for example, a block and tackle, a mechanic can lift an engine out of a car, without being Superman. And so that's the advantage of all this.